Yes, hi children. In last video, we had studied about the magnetic lines of force and the properties of magnetic line of force. And just let us recall them. Magnetic lines of force are the imaginary curved line around the magnet along which the north pole of freely moving magnet pass. It means along that direction only the north pole of given magnet exerts force on north pole of another given magnetic needle or the north pole of freely moving magnet. So we had studied all these things about the magnetic lines of force. Now Oersted, Hans Christian Oersted had given his experiment, and then he told that he gave this theory and idea that magnet can be produced by electric current, or he told that current carrying conductor behaves as magnet. To show that he did this experiment, that experiment I am explaining, and in next video I will show you this activity that current carrying conductor behaves like a magnet, or electric current can be used to make a magnet. So let us start Oersted's experiment. I am explaining this one. I think you will try to understand it. If there is any confusion, in comment box you will ask me how it happened, miss, and what is there. So let us see. This is what Oersted's experiment. For what? To show that electric current can be used to produce magnet, or current carrying conductor behaves as magnet, or current carrying conductor exerts force on magnetic needle, and also we can write it causes motion in magnetic needle. Current carrying conductor exerts force on magnetic needle and causes motion. So for the same activity, we can give three titles. What are they? Oersted's experiment, current carrying conductor behaves as magnet, or current carrying conductor exerts force on magnetic needle and causes motion in magnetic needle. So these are the three titles for the same experiment, same observation. So then let us start this one. We have, these are the two stands, A, B, these are the two stands. Okay, I think picture is clear. These are the two stands, this one and this one. AB is a straight conductor stretched between the two stands, and that wire is stretched in such a way that the wire is just parallel to this magnetic needle. Magnetic needle is on the stand, and it is just what we can say, it is the freely moving magnet. As it is pivoted on the stand, so it can change its direction, okay, of its own. So when it is kept over here, its one end will point towards the north direction, and other end will point towards the south direction. Now the conductor is stretched parallel to the magnetic needle. So by hand I can show you that, suppose my lower hand is like the magnetic needle and upper one is conductor, that is parallel to the magnetic needle. Now the two ends of this conductor are connected to battery and switch here. So earlier we see that while we do this setup, we see that the magnetic needle is parallel to the conductor. Now as soon as we switch on the current in the circuit, in the wire, now what we see that the magnetic needle changes its position. Magnetic needle now aligns itself perpendicular to the conductor. So I am showing you the new position of magnetic needle by this green ink. Now the direction of magnetic needle will become this one. So over here the magnetic needle will come, north and south pole will align itself like this. So what do we conclude from this one? That something is there near the magnetic needle which changes the position of magnetic needle. Now suppose that we switch off the current in the conductor. Again we see that magnetic needle has become parallel to the conductor. Again we switch on the current. Again we find that magnetic needle aligns itself perpendicular to the conductor. Children, did you understand? So the magnetic needle has become aligned itself perpendicular to the conductor. So as I had stretched my hand, so the magnetic, this hand representing conductor and this one magnetic needle. So magnetic needle will align itself perpendicular to the conductor. It will become like this. So and when we switch off the current, again it becomes parallel. It means something happens like the magnet around this conductor, means magnetic field is produced around the conductor. Due to that, this magnetic needle changes its direction. A force is exerted on the magnetic needle. Due to that, it changes its direction. And nothing else is there which could change the direction of magnetic needle. As I am showing you here that this is the magnetic compass, magnetic needle. And when we keep it, then its two end will point towards the north and south direction. But although we rotate it, we see that its direction doesn't change. Its one end will point towards the north and other end will point towards the south. But when we bring a magnet near it, it will change its position. So magnet exerts force on this magnetic needle to change its direction. So it means we can become clear over here that magnet-like property has created around the conductor. Due to that, the force is exerted on the magnetic needle and it changes its direction, and the magnetic needle is set into motion. So three things we can conclude from this activity: that a current carrying conductor behaves as magnet, current carrying conductor exerts force on magnetic needle, and current carrying conductor causes motion in magnetic needle. Children, suppose if we reverse the direction of current in the conductor, suppose we change the polarity of the battery. This end B is connected to positive terminal and A that of the negative terminal. So now the current will flow from B to A, and when we switch on the current, again we find that the magnetic needle aligns itself perpendicular to the conductor, but direction of motion of magnetic needle's north pole will be opposite to that in the previous case. When the current was flowing from A to B, the deflection of north pole of magnetic needle will be reverse of that when the current will flow from B to A. Again, when we switch off the current, we find that the magnetic needle becomes as it is when no current was flowing through the conductor. So this activity shows all these things. Children, suppose if we keep the conductor just below the magnetic needle but parallel to the magnetic needle, again we see deflection in the north pole of magnetic needle, and that will be reverse of that in the previous case. Okay, so this activity proves this thing that we can use electric current to produce magnet, to make a magnet. Now children, next video we will study about the direction of exerted force and in which direction the magnetic needle will move, what will be the shape of magnetic line of force around the conductor, and on which thing the strength of magnetic field around the conductor will depend upon. All these things we will study in next video. Thank you children for watching this video, and if you are watching, if you like this video, then support me, subscribe and like it, mention some comment so that I can feel better, I can feel good. Thank you children for watching this video.